In today's lesson, we'll be learning about the definition of the derivative and how it's related to the slope of a curve at a given point. The slope of a curve can be represented with a tangent line. A tangent line is a line that crosses a curve at exactly one point. So I'm going to go ahead and draw for this example a tangent line at point P. Now that tangent line, it's important that it only crosses at P and that it represents the slope at P. So you can see how this line, for example, does that. So our job is going to be able to figure out the slope of this line. Now that's a little challenging because there is only one identified point on that line because it is a tangent and only crosses at that one point. So our job in this lesson is going to be to begin by drawing in a different kind of line. So what I'm going to do is I'm going to identify some point up here. I'm going to call it point Q, and I'm going to draw in a line that goes through both P and Q. Now this is not called a tangent line, this is called a secant line. A secant line is a line that touches or crosses a curve in two places, in this case at both P and at Q. So what we're going to do is we're going to try to find the slope of that line. So what we'll do is we will identify these 2 points with some coordinates. I'm going to call P, since that's the one I'm interested in, I'm going to call its x value x, and I'm going to call its y value f of x. It's the corresponding value. For point Q, I'm going to name its x value a little bit different. I'll call this distance between P and Q h. So if this is x, then this x value would be x plus h, and the corresponding y value would be f of x plus h. Now what we want to do is we want to talk about the slope. So I'm going to write here and below my work the slope of the secant line. The secant line is the line between P and Q. And to find the slope, I'll look at the change in y over the change in x. And the y values are identified over here. They are f of x plus h minus f of x all over, those are the y values, so I'm going to use the x values. And since I started with point Q in the numerator, I'm going to have to start with point Q in the denominator. So the change in the x values will be x plus h minus x. Now that denominator can be simplified because the x and the opposite x can cancel out. So the slope of the secant is going to equal the change in the y's, again f of x plus h minus f of x, all divided by h when those x's cancel out. So this is what the formula is for the slope of a secant line for 2 points that are h units apart in the horizontal direction. How does that relate to the slope of a tangent line? Let's take a look at some additional pictures. I have here 4 different pictures drawn. Now, each of those has the same curve, and each of them has the same point P. And in each case, I've drawn the blue tangent line. The difference between pictures 1, 2, 3, and 4 is where Q is located. In the original picture, point Q is exactly where it was in the previous example. In the second picture, Q is much closer to P. The h distance is smaller. And the third picture, Q is even closer to P, and again, h is smaller yet. And in the final picture, Q is even closer yet to P, and h is as small as all of them. When you look at each of the secant lines that are drawn in red, you can see the one that most closely resembles the tangent line is the point where Q and P are closest together. Imagine, if you could, what would happen if Q and P were exactly one and the same. If they were exactly the same point, then this would in fact be the line in blue. It would be the tangent line, and the value of h would be 0. The problem with actually making Q and P exactly the same point is that our formula would kind of fall apart. We would have f of x plus 0 minus f of x all over 0. The numerator would become 0, the denominator would be 0. We'd have 0 divided by 0, which is undefined. So instead of saying h equals 0, what we're going to think about is this process of h getting smaller and smaller. The smaller the value of h, the closer to looking like a tangent line it is. As h gets infinitely close to 0, P and Q get infinitely close together, looking more and more like that tangent line all along. So instead of saying h equals 0, what we're going to do is we're going to write in words this: LIM, which stands for limit, as h gets infinitely close to 0, of this slope of the secant line. Again, looking at the picture, the closer h is to 0, the more like a tangent line it becomes, and this formula is our slope of a secant. Putting that on there is the derivative, f prime of x.